Okay, hi all. My name is Marco Mancini, and I am a cloud technical evangelist at OpenNebula. Today, in this presentation, I'm going to talk about the solution that OpenNebula offers for the deployment, scaling, and management of a container-based application through the provision of Kubernetes clusters. Now, Kubernetes is a powerful open source engine for orchestrating containers at scale. So let's see how OpenNebula uh, is offering this solution. So first of all, in OpenNebula, you can provision Kubernetes as a service. So you can build a multi-tenant self-service environment for provisioning and execution of Kubernetes clusters on a shared physical infrastructure with enhanced security because thanks to the additional layer that is provided by the hardware virtualization, now you can isolate resource pools on the same host. Also, you can automatically deploy and manage multiple Kubernetes clusters across different environments that are managed by OpenNebula. So, for example, on premise, on the edge, on cloud locations. In this way, you can enable the orchestration of large-scale container-based application, and also you avoid a provider lock-in, since you can deploy Kubernetes anywhere with the configuration you want with the same process. Okay. Another important feature is that in OpenNebula you can mix container-based application that are orchestrated by Kubernetes cluster with hardware virtualization workloads like virtual machine. And you are going to use only a single control, say central management for all your workloads, so a single pane. No, so you are going to reduce complexity, you are going to reduce consumption and operating costs. So you can so your management, or your life cycle management of Kubernetes cluster is really simplified, since you can easily deploy, resize, over provision if necessary. Okay, so now how in OpenNebula now you can provision Kubernetes clusters. So what we have done, we have built an appliance. So we have built a CNCF certified appliance that is available from the OpenNebula public marketplace. The appliance is based on Ubuntu distribution and on Kubernetes 1.23. The appliance allow you to define production clusters because it's multi-master ready. I will be back on this in the next slide. It integrates different features for networking. So we provision with the Canal CNI network plugin. We have integrated the Longhorn distributed storage solution, the CNCF Longhorn solution for the persistent volumes. And also we integrated Metal LB load balancer, so for exposing Kubernetes services that are deployed in the clusters. No, so in order to access applications that are deployed and provisioned in your Kubernetes clusters. Now, Kubernetes appliance is implemented by using the OneFlow. So it's implemented as a OneFlow service. And OneFlow allows you to define, execute, and manage multi-tier application in OpenNebula, what we call services. So these services are composed of different groups of virtual machine that are interconnected, and that can have deployment dependencies between them. Okay, so each group of virtual machine is deployed as a single entity, and this group of virtual machine are called roles. So in the Kubernetes appliance, we have defined different components, so different roles in the OneFlow service. In particular, we have defined the VNF role, and this is based on the VNF appliance that is available from the OpenNebula public marketplace. and it's used as a load balancer for the control plane. So for the master nodes. Then we have the master nodes, right? That these are the components that are manage the main component of the Kubernetes cluster in order to be managed to deploy applications. That is they manage the etc database, the API server, the controller manager, and the scheduler. Okay. Then the third role is the worker. So these are the nodes where you run your workload. And finally, we have the storage role. So these are dedicated nodes for the persistent volumes. As I said, in one flow, each role can depend on other roles for the deployment. And so usually a role is deployed when its parent is ready. So for example, the master depends on VNF. So only when VNF is ready, the master will be deployed. Okay, so if one flow takes this dependency into account, so we'll deploy first VNF and then we'll deploy master when the VNF is ready, is running and ready. As a default, the one for service is configured. So you have only one single server for each role. So you have one single server for VNF, one for the master, the worker, and storage. So this is not a non-high available cluster setup, but one flow. The one flow service in OpenNebula allow you to also to scale the service, so you can scale up or down depending on the needs. So you can add or remove virtual machine for each role. So in the case of an high available cluster setup, we can increase the number of virtual machine, for example, for the VNF. So we can have an high available load balancer, we can have multiple master, we can have multiple worker nodes for the workload according to the needs, and also we can have multiple storage nodes, for example, for replicas. But I will now be more precise about each of these components and how we can build also an high available Kubernetes cluster. So the point is that I mean, if you need a development environment, you can just, for example, deploy the Kubernetes appliance with the default settings. So you have one server for each role, and then you can use at the development environment. If you want a production environment, you really need to go from a single server, not available, high available cluster to an high available cluster, because what we need is that we should have no single point of failure. So in a single master cluster, we have important components, like the API server, the control manager, that just rely on a single master node. So if this single master fails, you cannot create any more service or pods. The point is that in the single master, the master manage this critical component, also like the etcd database, right? The scheduler. So if it fails, you cannot access anymore the cluster and the worker node, so everything will be lost. So in order to set up a multi-master, we are going to use multiple master nodes. In this setup, each the most important components, are replicated on multiple masters, usually 3 masters. So if any of the master fails, the other master keep the cluster up and running. So the multi-master setup protects against a wide range of failure. So you can have a failure on the master a failure in the etcd service, or you can have a failure due to the API server and so on. So we have, in this way, we have an high available system for the cluster, right? So what we need in order to reach, to communicate with the master, we need a load balancer in front of the multiple master. So with the VNF role, we are going to provide this load balancer for the available multi-master control plane. So we can define this control plane endpoint virtual IP, and so the user with the kubectl will just connect to this to the API server that is available through this virtual IP that is exposed by the VNF nodes. Clearly, in order to not have a single point of failure on VNF, we can have multiple VNF that are based on keep alive. So we can scale up also this component to, for example, to two nodes, and then also we can keep this in high available setup. Okay, so you can define when you instantiate you deploy a Kubernetes cluster, you can use this context parameter in order to set up this virtual IP for connecting to the API server of the multiple master. Regarding also the persistent volume, as I said, we have integrated this the Longhorn, the CF Longhorn solution that is a lightweight, reliable, and powerful distributed block storage system for Kubernetes. So Longhorn implements this distributed block storage by using containers and microservices. So Longhorn creates a dedicated storage controller for each block device volume, and then synchronously replicates the volume across multiple nodes. So we have multiple replicas on multiple nodes. So in the Kubernetes appliance, we have the storage row that allow us to have multiple nodes where we can keep the Longhorn replicas. Okay. The storage nodes are tended with the no schedule, so deployment of regular pods are not possible, is prevented on the storage nodes. And the other point is that by default, we define two storage classes when we deploy Longhorn. So the storage classes are called Longhorn and Longhorn Retain. So when you use the Longhorn Retain storage class, and this is useful in order to prevent any deletion, accidentally deletion of some data. So when a persistent volume claim is destroyed, the persistent volume is not destroyed, so must be destroyed manually when you use this kind of storage classes. So as I said, in the default setup, just one storage node is deployed. So if you lose that storage node, you cannot access anymore the data. So if you want to have an high available solution, you have to deploy multiple storage nodes. So replicas are kept on different nodes. Okay, so let's move to the other feature, to the last feature. That is about the load balancer service. So this is needed for to access application the pods, the deployments outside of the Kubernetes cluster. So beside the node port or external IP, we have provided this service that is a flexible solution for accessing applications that are deployed on the Kubernetes cluster. And we have used the Metal LB load balancer provider that is configured by default as an ARP layer 2 load balancer. So that means that when you define the range of IPs for the load balancer service, these IP are routed to one of the Kubernetes nodes by means that are outside of the scope of the appliance itself. Metal LB supports also BGP layer 3 load balancing. So if you set up this dynamic routing protocol, then you can provide, when you instantiate the Kubernetes cluster, you can provide the configuration by using a contextualization parameter, and then you can use a base 64 encoding for your configuration file. So once To define this range, you instantiate the Kubernetes cluster, and then you use the load balancer service type. You can access, the Metal LB will assign one of these IP in the range to this to the service, and then you can access by using this IP the service. Okay. Okay, so these are the most important features that I wanted to introduce in the talk, and then I'm going to show you about this appliance by doing a demo. So the demo will show you the most important step. So the first step is how to import the Kubernetes appliance within your OpenNebula cloud environment from the OpenNebula public marketplace. The second step is how we can instantiate this appliance in order to deploy a Kubernetes clusters on some of the cluster resources that are available in your OpenNebula cloud environment. And then we are going to use the configuration file from the Kubernetes cluster in order, and using kubectl in order to deploy an application on the Kubernetes cluster. By showing some of the features that I talked about, so the persistent volume, the load balancer type, and so on. So you can we can see how they are provisioned in the Kubernetes cluster by OpenNebula. And finally, I will also show how to scale the cluster. So we start from a configuration, from a setup, and then we can use one flow feature in order to scale some components, like for example, having multiple master for an high available setup. Okay, so let me go ahead and to show you the demo. Okay. Okay, here we have the Sandstone graphical user interface, the dashboard. So here we already deployed a cluster that has a couple of hosts, KVM hosts. We have defined the virtual networks, two virtual networks, and the three data stores, for the images, the VM, and the files. Regarding the virtual networks, there is a public network with addresses range. This will be used, 100 IPs will be used for the VMs, and we are going to use the other IPs for the control plane endpoint and for the load balance. Here from the apps storage app, we are going to use download the Kubernetes service appliance, and we are going to import in the OpenNebula cloud. Once we import, we have different templates for the different roles. You can update each template according to your needs, in order to customize. You can customize your memory, the CPU, and the storage, and so on. So we have three templates: the VNF template, the master template, and the storage template. The master template is used both for master and worker nodes. Okay, so once you have updated your templates, we can look at also the service template. This is the one flow service. Here we have defined the 4 roles. So we have the VNF, the master, the storage, and the worker roles. You can also update the service template. You can scroll down to the roles. For example, the VNF, you see we have one VM. By default, for example, we can put here 2 number of VMs. In this case, we are going to change the number of VMs that are deployed at instantiating time. You can change also for the other roles. We can change, for example, the cooldown. It's the time between 2 scaling of operation. And then you can do this for the different roles according, or you just keep what are the default values, and then you can use one flow features to scale, for example. So here we are going to instantiate the service. We are going to select the public network, we are going to define the endpoint virtual IP. As we said, this is the IP that we are going to use to connect to the API server, and then we can use a range for the load balancer IP. So as you see, these IP are not in the range of the VMs IP that will be used by now OneFlow when we are going to deploy the service. Okay, so as I said, the first role is the VNF. So this is the first role that is being deployed. Once this is deployed and this, the VNF is ready, then OneFlow will also deploy the master. As you can see, we have set up 2 VMs for VNF, and one for the master and one for the worker and the storage. This is the IP of the master. So now what we have to do is to download the copy, the Kubernetes config file from the master node, for example, to our local laptop. And you can find the Kubernetes config file in etc kubernetes admin.conf, and then you can put in your .kube config. We can look at this configuration file, and as you can see, the IP that is set, this is the virtual IP, so the console claim endpoint VIP. This is what we need now to communicate with the masters. So here we can see that still only the master has been configured, has been set up. Usually this requires some minutes also for the worker and the storage to be configured. So we can move forward a couple of minutes, and then we can see that also the nodes are, also the storage and the worker nodes are now ready within the Kubernetes cluster. I prepared the YAML file for the deploy for not sure to deploy an application. So we have a deployment based on Nginx image. So we have changed the home page, the HTML file, and we have also associated the volume to this deployment. As you can see, there is also a load balancer service type that in order to expose now the Nginx service on the port 80. And as you can see also here, there is a persistent volume claim based on the Longhorn retail storage class. So what we can do here is to just deploy this multi YAML file for the for this Kubernetes application. As you can see here, we have the deployment. The pods is still creating the containers. It is pulling the image from Nginx, and then here we can see that this IP address has been used for the load balancer in order to access the Nginx. Also, we have a persistent volume that has been associated to the Nginx deployment, and this is based on the storage class Longhorn. So let's check again the pods. Now it's running. And then we can access now this by using the external IP that has been associated to the pods by Metal LB. Okay. Now let me show how to you can scale your cluster. For example, we are going to here to scale the master. So if you want to have multiple master in order to have an high available production system, you can scale here to 3 masters. And then what is happening is OneFlow is going to deploy, provision other 2 master VM. So now it's in the scaling phase, and here you see that the service is scaling. So other 2 masters have been deployed. So this is going to be in a scaling state until the 2 masters are ready. So this usually takes a couple of minutes in order for to be configured the masters, and when the scaling process is finished, so the masters are ready, then you can also do some other scaling operation. As you can see here now, if we do this kubectl get nodes, we will see that we have other 2 masters that have been added to the cluster. Now we have this multi-master high available setup. And as I said, when there is no more scaling operation and also the cooldown is done, you can scale with other rows. For example, you want to have another replica for your persistent volume, you just scale your storage nodes, and then, as you can see here, another storage node is being deployed. And so you can do this also for your workload needs in order to scale up also, for example, the workers. And this is finish the demo. So I think this is you can check the new release of OpenNebula Archer that is now available. I thank you all. If you have any question, please ask. I will reply in the chat. Okay, thanks to all.